So hi, now I'll show you how to start iTransformer. Basically, you have to go to the bin folder and then you have to execute the iTransformer shell script. Once you do it, you'll see such a window. The next second thing that you have to do is to create a new project. For example, test 345. Once you create a new project, you'll see all those menus enabled, and we will start on SNMP network discovery. For the purpose, we have first to configure the resources. So basically, the SNMP resource is the default one. It's used for all kinds of SNMP queries against the devices. But also those resources are used, like this one is matching on the Juniper device types, so it will be used for Junipers, this one for Huawei, this one for Cisco. And you can even create such kind of resources in which the match will be on device name, and that specific resource will be used for the discovery of this particular device. Why we did it like this? It's because sometimes some devices require specific timeout values or has a specific communities, or the port might be different, or the devices could be some small or large number. You see, for example, this is the default resource, and it's used mostly for the get requests that our discovery algorithm will do. So it has a very small timeout, 500 milliseconds. It doesn't retry, just one. And it's to snmp.c. So I'll save my resource. So if I haven't changed it, but if you change it, you have to change here the communities. And timeout. I will save it for now, yeah. And I'll exit. Then I'll go here and I'll start my discovery window. So I have a Dynamics network. This one here, you see the 8 devices, and I'll start discovering it now. So I know that one of my devices is on node 3. See, auto label. If you have label here, ABC, basically in your project folder, the discovery mechanism will create ABC folder. It will upload all the files created by the discovery in it. If you have auto label, it will create a version 1 folder and then version 2 and so on for each discovery you start. So I'll start mine. And you see that basically the algorithm starts to pull the first device. Then it will jump to the second one, to the third one, to the fourth one, and so on in our network. Yeah, you see now it's pulling another one. We can wait for it, or we can just go to File, Open Graph. This will drag us to our network folder where is our first version, and we can try to open the undirected GraphML files, which should create a view like this in your action. Since the discovery algorithm hasn't stopped yet, basically it will be good if we continue to press from time to time the reload button, which will bring us a newly discovered devices to the screen. Yeah. So what you can do with this, you can move the graph, you can reload it, refresh it, you can redraw around certain node. For example, if I click here and I put like one hop, here these are I think I'll show only two. It will show me only two devices. If I put 3 hops, it will show me everything that has been discovered. You can capture the screen. You can do many other things. Let me just check my discovery algorithm. Still discovering. You see now there are 4 devices discovered. So I'll press again the reload button. I'll get the 4th one. Yeah. I want to show you some stuff. This is new. Basically, before we didn't have the graph layout. So, for example, this is FR layout, but we have also KK layout, for example. It's more compact. We support also circle layouts like this. We have 50 devices, 50 devices here, okay. So we support also spring layout, which makes the network move. We have zoom in and zoom out. Basically I do it with the scroller of my Mac, but you can do it whatever other way. So if you go to the device, you see some nice tooltips like this. What is the device, which is the device type, what's the device name, what is the management IP address. If you go to the link, you see the information on both devices here, like on R4. This is IP address, this is the protocols used for discovery, for the discovery of that link. So you can have some path previews. For example, shortest path preview. It will allow you to select an initial node, and it will allow you to select maybe R6. Yeah. So it will show you the shortest path between the two nodes. Okay. We have also Dijkstra. This is a bug, but the first one works. It will calculate the Dijkstra shortest path. We have ranking algorithms. For example, between the centrality. It will calculate the ranks of the node. Basically, you see that our node R3 has the highest rank of them all. This actually shows that the rank basically shows the importance of the node in the network. So in our case, if we queue up 3, most of the shortest path in that network will fall. This is the idea. What else can we do? We can click on a node and get some reports out of it. For example, the device neighbors report. So here we see that actually this device has a lot of neighbors to TCDP on that interface. This is our management network interface, and several through OSPF that are on the serial links. Here I have shown just the serial one. And this reminds me that actually you can do also like this. You can apply different filters of the discovered information, and they will change the layout. So in this case you see some of the networks that were discovered, but actually the discovery itself doesn't work. So for example, this is my management network. You see how most of the nodes are connected to it. You see that there are some networks that are discovered, but we don't know what's on the other side. Yeah, we can plug in OSPF as routing protocol, so this is our main routing protocol, maybe BGP. No, we don't have BGP. Yeah. And some other. Cool. So one more thing I want to show you is how we can change the configuration of the node. Basically this is done to the node activation. So it will move us to the first one, it will enable us to change some kind of to apply some kind of a template on that node. So for example, set host name will allow us to change the host name of the device. I want my R1 to be named R11. Yeah. So you see actually this stuff, logging on the router to telnet, pass the username and a password. Then enable command, enable password. Finally, it has the config terminal and has the command no IP domain lookup and host name R11. So basically, we have changed the host name of that device. So now, if we go again to our discovery management tool, we decide to rediscover our network. Yeah. So basically, you see that now it will go to version 2. So we have versioning of the discovery process. And now yet another discovery will be fired. I'll show you the differences. In the meanwhile, I'll show you also some other things that we're able to do. And this is path activation, is very interesting one. It will allow you to apply such configuration changes on a path in the network. So we'll select again. Because we have triggered it on F1, it will ask us just for the B node. So, for example, this could be R6. And then it will go to R1 to ask us what we will apply. For example, I'll choose enable IPv6 routing, which will do IPv6 unicast routing as a command on the device. Then it will move me to the next node. Again, I'll choose enable IPv6 routing. Again, it didn't work here. Maybe the command is not supported. Okay, so the command for IPv6 unicast routing is supported, but the multicast one is not. If I choose it again, yeah, it works. Okay. Then we'll go to R6. And again, I'll apply v6 before unicast routing. I want to show something also quite cool. You have the option to get a new tab. So in the new tab, for example, you want to see everything, and you can apply different filters on the network. Yeah, so it's quite convenient for network engineers to review their network and see what's going on with it. You can close tabs, you can close graphs and reload them, but more importantly, you have some help here. It will move you to the user's guide of the tool, which is on our web page. Yeah. It's hidden, but here you see a couple of guides. They will help you a lot in learning iTransformer. Just want to check out what happened with our second discovery. Oh, it's finished. I can actually open it. Here you can see the version 1 of the discovery process and also the version 2. Yeah. And here you see actually this device comes with a new name. It's R11 because we changed its host name. What else what we can do is to diff the graphs. So if we want to diff it, we will have to go to the network folder and to select again the undirected graph ML, so directed graph MLs for the first version. Oops. And also for the second. So soon we will get such a screen in which running diff tool will appear. Now diff is completed. And here we actually see it visually. So what happened is that my device key is the host name. So this one basically the node with green appeared and this link appeared actually. So the node in red disappeared and that one disappeared too because of that stuff. This was pretty much everything I wanted to show. I just want to say maybe some words on the discovery parameters. This is how you can configure them. They are in such a file. So by default, if we don't know the device, we will use this kind of parameters. What means default? How do we decide that we know it or we don't know it? Initially, when we start the discovery process, each of the devices is asked about its name, its type, and its type. Yeah. So if the type is, for example, equal to Cisco, we will use that device. If the type is a Juniper, we will use this one. If the type is HP, that one. So if, for example, we may say that we want to change the device type of an HP routers by adding something here. So this will be fired nice SNMP walk request against the device. Just want to show you what's the result of that walk. So basically you will see such a file in your network folder, in your version folder. This is the device XML file. So this is the result of the discovery process on a single device. From that one, we generated another file called GraphML, which actually looks like this, much simpler. It has only nodes, yeah, and edges. So this is what actually is used for. I used to draw that graph here. So thank you for your attention. That's all I wanted to show. This is iTransformer version 0.5. It's still not on our source page, but it's coming up. Have a good one. Bye bye.